All right, let's get busy here. So today was supposed to be Zig. I'll see if I feel any better. Let's look at Zig here. All right, so I might feel better today. I might try and do like these three for the Civ this morning. I don't know. Let's see. So first of all, let's hop on to here and join the track. Okay. So let's take a look. It says we should go to the install page, sure. And we could do that, I guess. Let's take a look. All right, let's see brew. I usually go with brew. It's usually pretty painless. All right, so brew, install Zig, and we'll see how it goes. Okay, so fetching that, and then we'll see it. We'll see how it goes. Let's see. We can do a format Zig Zen. Should we see about this? I mean, I don't know. It's fine. So let's hit the hello world. Okay. Let's go over here. So, okay, so if we do test, what will it say? It says code generation. That looks good to me. Okay, so now let's go into the hello world file. Nope, not that one. Okay, looks simple, looks nice. Let's test. Okay, so let's submit that one. Okay, so we'll see if that's cool. Processing. And passed. Okay, cool. Alright, so now let's close these back down. We'll hop back over here and we'll do this next one. Love it. I always love it when they just make it easy. Alright, so for this one, let's see what we're supposed to do. Alright. Welcome to Civ. You bought a big box of random computer parts. Let's see. Benchmark program. Oh, okay. Sure, it should push your computer to the limits. Alright. Fair enough. Okay, so, yeah, this is simple, common. Create a list of all the numbers between 2 and your given number. Yeah, we know this. So then, do I want to take a quick look at the test? So, it just passes in a 1000 and a buffer. Let's see, do I know why the buffer gets passed in? It says buffer is undefined, and we pass that guy in to get out the actual. I'm not sure why the buffer is passed in. Let's see. Buffer length equals 200. Okay. All right, so presumably we're gonna put the primes that we find into this buffer. That's a little weird though, because like for the sieve, we're going to need like all of the numbers. Anyway, so this is a simple common one, but does that mean that I'm going to be able to do it well? Not necessarily. Let's see how well I can do. Okay, so the function is called primes. Okay, buffer limit, please implement the primes function. I don't think we need that, do we? So if we're here and we're trying to make some primes, should I have like a const list or array or something of numbers, probably? Okay, so let's find some Zig information. Zig const array. Can we do something like that? Zig by example. All right. Let's not make it weird or anything. Let's just say that we're gonna say, shoot. So in the test, you just say buffer. Okay, yeah, let's do that. So we'll say var, and what is this going to be called? Numbers, right? And then we'll just put a length, and the length is going to be the number that was passed in. And then we'll say U32. So limit U32. Okay, and then what else? So then we set it equal to something. So can we just say undefined, like they did there? And then if we say for, and then just say, let's see, let's look at our Zig for loop. When we see what this looks like, it should give us a lot of information. Okay. Okay, we iterate over array by value. Okay. So that we can do a range. Yeah, we want the range. Okay. So we'll say 2 through limit. Right? And then oh, so this one is I element. Okay. So if we want that I, then let's go 0 dot dot. And this will be I, n. And then here I'm just going to say numbers sub I equals n. All right. So that's the first part, just like populating that array. So then my voice does feel much better, but still seems not perfect. Okay, ignore the elements. You can do that. So we filled it in with the numbers first. So now we're going to go through and mark whatever is a prime, right? And it explained it like in a lot of detail in the README, right? So we list out all these or whatever and mark it as not prime or whatever. So then okay, so we'll go for and then it's just numbers, right? We're going to get n out of there. Okay, and then honestly, I probably do need the index again still. So for array, iterate by reference. Do we want to modify the array's contents? Not in the outer loop, but in the inner loop, yes. So I'm just going to mark it with a, here, let me put a comment. Zig comment. Language reference. Okay. Comment. Okay, let's do that. So here I'll just say I will mark the composite numbers by changing them to -1, right? Because we don't care about numbers that are not primes. Okay, so now we'll go 4, and then this time we'll do by reference, right? Numbers. But this time, do we need, okay, we need the I here. And then here, it's going to be I dot dot, because that's where we're going to start. Really, it's more like I plus 1 dot dot, because we're going to start with the next one. And then we'll say if numbers sub j mod n equals 0, right? And then let me look at the if statement as well. Zig if statement. If expression. If. Let's see. If. Here we go. Oh, interesting. So if a value, if b value, oh, let's look at it here. If a, okay, so I don't necessarily need that value. Okay, so I'm just going to say if this, so we want the parentheses, right? Then numbers sub j equals -1. Okay, so now another thing we need to check on is if this number when we get there is a -1 already, then we need to not do anything. So I would say continue, zig, continue. To jump to the next iteration of a while loop, use the continue keyword. I'm not sure if that counts for a for loop, but let's see. So we're going to say if, let's just say if n is not equal minus 1, and do this part. Okay. Okay, these are not matched. Let's put a, oh gosh. Let's put this here. Okay. Trix is back. Hello. Yes, Hexada Ghostmane. Yes, I am back. I've been sick like all week. So I'm doing the classic prime number thing in Zig now. And I have open how to do the most basic Zig things. How do you do the if in Zig? How do you do the for in Zig? This one seems a little interesting. How do we do an array in Zig? I've got the basic things here. Yeah, baby. All right, so if we've marked the composite numbers, then now into the buffer, we just need to put everything that we haven't marked at the end. I don't know if I've missed something. Let's see. So this should be numbers again. Numbers. And actually, this doesn't make sense either. We just want a number this time. So for numbers, and then if n not equal minus 1. Actually, let's not loop again. Let's just do it up here. So if it's not equal minus 1, let's put it into the buffer. So I'm going to say buffer index equals 0. And let's see. I'll say var. Var, yeah, there we go. Guess it's probably U32 or something, and I'll just say it's 0. And then here I'll say buffer sub buffer index plus plus equals n. So basically like that, I guess. Let's see, can we do increment? Zig increment operator? Yeah. Why are there no zig increment? Okay, I guess we can't do it. All right. So I'll say buffer index equals buffer index plus 1. Sure, it's fine. All right, so then I guess here we returned buffer, and let's see, did we see if we're returning things? I don't even know. Zig function return. Let's take a look. Return. Why do I have 1 gigabyte text file? You're asking me? I don't know. I'm guessing because you are probably having an LLM generate a lot of text. And if that's the case, I don't know. If it just kept going and going, it could get to 1 gigabyte pretty fast. All right. Okay, so we do return like this. Okay. There is 171 million lines of word test. Oh yeah, that makes more sense. If we just keep testing it, then we can get that file pretty big. All right. So let's see what this says when I do this. Okay, error, expected semicolon. All right. Cool. Let's put some semicolons in here. Return. Oh, another one. Okay, unbounded for loop. Let's take a look. Oh, I think that using the I+1 like that might be okay. So I'm going to say var start equals I+1. Should I put the type? I guess it's no big deal. U32, and then I'll just put start. Unbounded for loop. For start. Okay, that matches. Oh, right, of course. We have to put the end here. So where do we end? We end at limit? No. We end at let's see, do we have a length on here? Len field? Okay. So that is going through numbers, len. But if we do that, do we have to subtract 1 off of it? I'm not sure. Let's just see what it says. Okay. Local variable is never mutated. Okay, so do we say let instead? Expected semicolon after statement. Expected semicolon after statement. Let's see. Zig. Uh-oh. Hold on, I can read this. So if the text is a little small, but if not false is equal to false and not true is equal to false, then logically not false is equal to not true. So not true or false is equal to not false and true. Actually mean true equals not false, or is true equal not true what we really want here? I think the last one, oh no, true equals not true. Okay, I have no idea which one you really want there. It would be very hard for me to say which one you really want there. Okay, let's see. Expected semicolon after statement. Okay, so I have const. Oh, const. Const is probably what it is. Let was just a pure guess. Unable to evaluate comp time expression numbers limit. Okay. I think I didn't do that right. So we put the number in here. Okay, that part makes sense, I guess. And then oh, is that so different from what was in the test? I guess it must be, right? So in the test, we said var buffer lane u32 equals undefined. Okay, so what did I do? Var numbers limit u32 equals undefined. Okay, so we don't know what the limit is going to be, and that's what it was complaining about. Unable to evaluate comp time expression. Okay, so Let's see, is there something in here about a dynamic? If an array is compile time known, it can be repeated. Okay. Um, and if we don't know the size that it's supposed to be, is it like this? No. To infer the array's size, zig dynamic array. Let's say that everything is true, but would that cause problems in real life? In real life, saying that everything is true? I think that was in Assassin's Creed or something, right? In the first game, I think he says, nothing is, no, what does he says? Everything is permitted, and did he say everything was true or nothing was true? I'm probably making that up. Okay, let's see. So I don't necessarily want to make it at compile time. So we use the allocator. Okay, this sounds useful. So if we make some kind of allocator, and the allocator, is that described here? Allocator. Choosing an allocator. Wait a minute. Let's go up. So allocator was, is it here? Is it here? Okay, so what did they say? We do a standard, okay, so const standard equals import standard. They chose a standard heap general purpose allocator. That sounds fine to me, I guess. And then they got an allocator off of there. So what is this part? Dot with the squigglies there. Okay, so my size is not known at compile time. You can manually allocate the memory instead. Okay, so I think what we actually have to do is use the maximum size. Or at least that's what's going to make it easy for me. So I would say I'm going to use a maximum size here. And in the test, I think they said something about it being up to 1,000. So if that's the case, then I'm just going to use 1,000 as the maximum size. For now, let me make a note. Using 1,000 as the maximum size for now. So then that would be fine. But then that means that using this length won't help us at all here. So instead, I think I need limit -2. Okay, numbers sub I. U32 found U size. Oh, messed up. Messed up. Why did I get U size? Oh, wait. No, actually, I'm not sure. Numbers sub I equals N. Expected U32, okay. Found U size. I don't know. Let me see here. It's on 5? Okay, so 4, oh, interesting. 2 through limit. Okay, let's see if, can we, I'm gonna take a guess. I don't think it likes it. Okay, so zig typecast. Why does it zig typecast? Not that it matters, but U size. Okay. Int cast. Well, okay. But hold on. Okay, let's try it. At int cast. It says cannot represent integer value -1. Oh, of course. So, yeah, that's not paying attention. But I think 0 is fine, because they shouldn't be 0 either. Yeah, I think 0 is fine. They shouldn't be 0. Uh-oh. Uh-oh, what has happened? It says panic. Oh, understandable. Integer overflow. Uh-oh. This is gonna take longer than it ought to. This is not good. Oh no. Okay, so we came to here. It's pointing at the 2. It says panic integer overflow. Uh-oh. No primes under 2? Oh, shoot. No primes under 2. So they passed in a number 1. Okay, so we can handle that. So I'll say if limit less than 2, return buffer without having put anything into it, right? Okay. Oh, okay. It's looking like progress. Okay, so let me go up to the top of this. Okay, slices differ. Oh, wow. Yeah, these aren't right. Expect, okay. Oh, the buffer is full of garbage. Well, I wasn't ready for that. Understandable, I guess. So, let's see. What am I going to return instead? Was there anything in the help? Okay, running the tests. Hmm. Yeah, honestly, I'm not sure why we thought we needed a buffer like that. This might take me a while. Oh, this is dumb. Okay, so return 0 U32. So I'm going to say var result 0 U32. Let me see, what was it again? Local variable. Oh, okay. U32 found type. Oh, where did that go? I thought I'd had it there, but I guess I was just dumb. array literal requires address of operator. Panic. Oh, okay, so we got to another point, and now we panicked again. And so this time, uh, it was only like 5 minutes ago. What was the problem before? Oh, this is in, which test is this one? Does it say which test? I think it does, or it should. In primes test? Oh, find first prime. Okay. So if we go, so if this, so, okay, I definitely don't have it right. Okay, so we're gonna say it's 2, so we're gonna proceed. We're gonna put some sort of thing here. We're gonna put some numbers in here, int cast n everywhere. And that's 2 through limit, and I didn't see zig range operator. I didn't see if it was inclusive of the last thing. So if we do 5 through 10, is 10 included or not included? Hold on. Maybe it should be a while loop. 0.12 unstable version. Yeah, I think this was already fine. But if it's range 2 through 2, I guess we did get past that part, right? So I don't know if anything happened there at all. Maybe we just skipped over it. If we just skipped over it, that's no good. Integer overflow if it's okay, so this is find first prime, start through limit -1. And so, okay, so let's look. So we think we're going through whatever numbers. Oh yeah, that's never gonna work. That's crazy. Yeah, that shouldn't be it at all. It should be, yeah, this whole thing is dumb. It should be 2 through limit +1, same as here, which really means that all this other stuff should be up there. So let's delete. And then this is pointless too here. So, and then nothing's happening here. Let's get rid of that then. Okay, so does this make more sense? 2 through limit, I put a +1. I put a +1 thinking that Uh, the range does not include the upper number. Zig range operator. Language reference. Range. Dot dot. Oh man. Hold on. Range. For, okay. Iterate over a portion of a slice. Is it more like a, okay. Use the range syntax. Range. Use the range syntax, fine. Okay, so less I is less than end. Wait. Shoot. Where is it? Where is the range syntax? Ah, okay, can be specified using this. They are inclusive of both ends. Okay, but this one has 3 dots. The other one has 2. Okay, zig range operator, 3 dots or 2. 2 dots is exclusive, 3 dots is inclusive. Is this a real source? I think so. Okay. So let me put this note. I think that 2 dots is exclusive and 3 dots is inclusive. So if that's true, then I should get rid of this and just use 3 dots. Okay. And here, do I want to go through limit -1 like that? Oh yeah, what do I want to do here? Yeah, see, I've messed up this whole thing because now now I'm just trying to go through the range and this doesn't make any sense. It's never going to be 0 here. Instead, we want to say what it is in the numbers. So we want to say const, and what do we want to call it? Number equals numbers sub I. It is number sub I, right? And then that goes there. And then, man, I messed up this whole thing. It's all just confusion. Okay. So if number is not equal 0, then we'll set n into there somewhere. We'll increment the buffer index. We'll say start is here. And then we'll go through limit -1 here. Yeah, that part is right. J. So if numbers sub j. Okay, so but then this, we can't do this. So this has to be start +2. That's so dumb. Through limit. Oh my gosh. All right, so then if, so let me just call this m maybe. m mod n. Oh, yeah, okay. Then numbers sub j equals 0. Okay, so we'll set the zeros wherever we found a composite number. And if we haven't already found it to be a composite number. I hate it. I hate it. I hate it. I hate it. I'm gonna try it, but I think I'm gonna step outside for a second to redo this. Expected comma after operand. Is the 3 dot not gonna work? That's what they were complaining about, right? So in that case, if it's the 2 dot, then we have to add 1. And here as well. Use of undeclared buffer index. Okay, I messed that up. Expected type U32, found U size. Okay, okay, okay. Yeah. All right, all right. Okay, I gotta clear my head a little bit. I'm gonna step outside and try and finish this. Man, I've been at this forever already. Um, let's see. 1 passed, 0 skipped, 4 failed. I like that. Okay, so let's see. What's the first thing it says failed? Okay, so 0, 2, and then we found length 200 and all this nonsense. Um, okay, so zig, um, so we tried returning this buffer, but that's not what we want at all. Slice of array, something like that. Zero through buffer index. Is that different? All 5 tests passed. Ha! Okay. I am gonna try the next one, which is bash. But I gotta step outside first. I feel crazy after doing this. Oh my goodness. Every time, I feel crazy. Alright, so it says processing passed. Okay, well, I mean, that's a relief to get past. That one made me feel pretty crazy. I guess it didn't take all that long. Probably about twice as long as I would like, but whatever. Alright, so let's go back to here, and the next one is going to be bash. Okay, I'm gonna step outside and come back in like 5 minutes. Hold on, where did I put my keys? Oh, right here. Okay, I will be back in like 5 minutes. All right. Ah, bash. Bash, bash, bash. This one is gonna expose me. No, I don't know. Maybe it'll be easy. All right. Maybe it'll be easy. I don't know. Let's join the bash track. So for this one, I'm going to assume that we don't need to install anything. Let's just try running it. Okay, so we're gonna go to bash. I think this is the one that's really going to expose me. Okay, let's try running the test. Uh, bats. Oh, what is bats? I don't even know what that is, actually. It must be bash test suite or something like that, right? Bats. Okay, I think there's something in the README. Let's see what's in the bats file. It says at test. Okay, let's see what's in the README. So it says we're going to use bats. Does it explain bats? Testing on the bash track. Okay, so we need bats. Okay, here we go. Here we go. Bats. Can we install this with brew? I love brew. Brew install bats. Bats core. Bash automated testing system. All right, here we go. Okay, here we go. Let's see what we got. Okay, expected hello world, actual goodbye Mars. Okay. Hello world. Okay, so now it says okay, so let's submit. Hello world dot sh. Yeah? Okay, cool. So we'll take a look at that. It says passed, so we'll mark as complete. Okay, now we're gonna try the sieve in bash. And honestly, I'm a little nervous about this one. Okay, is this it? Wait. Okay, bash sieve. Here we go. Let's close these. Okay, sieve. Okay, let's see what we've got in there. Okay, first of all, let's see the tests. Okay, so okay, not a ton of tests. No primes under 2. It's just gonna say run bash sieve sh and pass a 1. Okay, so then let's see what, if anything, did they put in our shell file to start us off. Oh, okay. The following comments should help you get started. Bash is flexible. You may use functions or write a raw script. Complex code can be made easier to write by breaking it up into functions. However, this is sometimes overkill in Bash. Please remove these comments before submitting your solution. Fine. So, let's see. So if I look at what we did on the last one, so here's all we did. I mean, it's not, yeah, it ended up not a ton of code. I ended up with just one loop. Um, So I'm gonna probably try to take the same approach basically in Bash, but I'm gonna have to look up everything same as I did for Zip. All right, so Bash for loop. Because honestly, I don't really know Bash programming. I really don't. Every time I've had to write anything, I've looked every single thing up. All right, how do I write a for loop in Bash? All right, so they said for I in sequence 1 through 10. And this one, see, the reason I think this one exposes me is because I really do feel like I should know this syntax. I mean, I should know this syntax, but I don't really, honestly. Okay, so range here is inclusive. Okay, so I'm just gonna copy, I'm just gonna copy and use that as my starting point. Whoops. Okay. So this is what I'll use for my starting point. So then, do I even remember how to get what's passed in? Honestly, no, off the top of my head, no, I don't. It's like I think it's just $1 or something, right? $1 in Bash. Yeah, okay, so this should be $1, I guess. So we'll go up through there, inclusive. Double quote to prevent globbing and word splitting. Okay, sure. Double quote to prevent globbing and word splitting. Okay, so, but I don't actually want to echo this. That was just in there as an example. So what I actually want to do is whatever was in here. I'm just probably gonna put that into my file. So that I have a reference. Oh, how do we do bash comments? I had a big old comment in there. I think you just put a... Oh, I think I learned something. So if I do vline and I go all the way down and I press hash and then escape, no. Oh, okay. If I do vline and I go all the way down, I'm trying to learn something, and then I press I hash, no. Okay, I don't know what it is. So comment that out. Here, hold on, let me look. So vim multi-line insert. Insert the same character across multiple lines. Move the cursor. Control V. Oh, I was in... Okay, so Control V is V block. That's what I had wrong. So if we do V block instead of V line, then what does he say to do? Press big I and then type what you want. Yay! Okay, cool. All right, I learned something for once in my life. I learned something. All right, so for this one, I guess we need to start with 2. 2 through whatever was passed in. And then in our test, we know it's expecting... Okay, so it's basically a string with everything in it. Okay. Okay, okay. This one makes me nervous, honestly. So, for I in $sequence2. All right, so we know there's going to be an inner loop as well. So I don't need a buffer index because I'm just going to append each number, each prime number onto a string, basically. So I guess let me look at bash string append. I do feel bad. Like, some of these are things that I should for sure know. All right, so yeah, we can just totally do that. So here I'm gonna say result equals this. Get rid of those. Result equals this, okay. And it says result appears unused. Okay, well, I will be using it. And then, okay, so that's what we do. Do we need to check if limit less than 2? Yeah, honestly, probably, yeah. So let's go if $1 less than 2 do I need to look it up. Bash if statement plural site. So we would go if. Oh, does it have to be in those? Okay. All right, so then put semicolon, then equals is for numeric comparison. Let's take a look. Bash less than. Okay, so here do I have to go LT? Bash LT. Okay, so if $1 is less than 2, you need a space? Okay. It's helping me, it's helping me. Okay, so then echo. So are we echoing or what are we doing in the test? So it's supposed to be, so we run, and this expectation, is that what's expected to be like echoed out? I think maybe that'll be something to check on at the end. So then here I'm gonna go else. And we'll look again at what it was about the else. It's this, right? Okay, so then else. And then this goes here. And okay, so result equals this. All right, so I did this if limit less than 2. Then we're going through this. Okay, so number. Okay, so now I'm gonna want some kind of an array or something. Bash array. Okay. Yeah, this one exposes me for sure. All right, so we want to set numbers. So I set result, but I want to set numbers equals, and then we kind of like create an empty array. Numbers appears unused. Okay. So then down here, where do I use numbers? Right here, right? Okay, so here we are going to say if numbers sub $I, and again, is this how we do it? I think so. Okay. So if this, and we say equal, and I'm going to say 0, should I see if there's a not equal? Bash EQLT not equal. Less than equal, greater than equal. So NE for not equal, okay. So if it's not this, then, okay, so then at this point, we have to put the number into our result. So we'll say result equals, and then it's going to be dollar result space dollar what? I? This has to be subtract 2 here. Trying to do math. So I'm going to say index equals $I minus 2. And then here I'll use index. Couldn't parse. Okay, so if numbers sub index dollar, is that better? No. Then okay, so not equals treats this as an arithmetic expression. You compare as string. Okay, I don't want to compare as string. I do want to compare as arithmetic. Okay, so then the result equals this. Okay, so then what's the next part? So then we increment the index? No. Wait a minute. Oh no, we don't need to do anything with buffer index. Then, so then we need to loop. So we're gonna go for j in, we'll say sequence. So this one goes $I through $1, I believe. Yeah, I think it's through $1. Do done. Couldn't parse this for loop. Okay. So then in here, we need to say if, and then we need an M and an N. So, okay, so we're going from $I. So $I is the M in this case. So basically, I think I just need to say if, oh, bash modulo. Okay, so I'm going to say if dollar, and I'm going to go $J mod $I, and then did we say equal? Yeah, equals 0. And so then we say numbers sub j equals 0. Honestly, this probably doesn't really make that much sense. I think I'm just going to use I here. Then numbers sub $J equals 0. So does that cover everything that I had in my previous solution? I think so. No, not yet. So when we get to the end, then we need to echo result. All right. So what does it say? Okay, 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 okay. No, it's saying okay, but they're skipped, so we have to go and unskip them. Right, so we comment that, comment that, comment that, and comment this. Okay. Okay, now let's see what we say. So no primes under 2. So that one was okay. So then here we said expected to, okay. Well, that was a dumb error. Civ dot sh. So this, of course, should be $. Okay, so what did I get? Expected to, actual nothing. Okay, so I didn't get anything in there. So when I did this, I'm pretty sure I didn't do that right. And they did say exactly how to do that somewhere in here, and I just basically spaced it. I know somebody showed the exact thing in one of these. This one. Okay, so they put it in squigglies, and I just didn't do that. Okay, so now it says, okay, so I still didn't get a two. Oh, I didn't get anything anywhere. Okay. Messed up, messed up. Okay, so it says foo equals foo world. So when we went to echo, it was a little bit different as well. But actually, I still don't know if this is even how it wants the outputs. Okay, let me see this again. Okay, so in the test, we're going to run this, and assert output is as expected. Okay. So when I just echo, is that the output? Oh, here, let's actually test it. So if we do um so nothing comes out. Okay, so that confirms it. Okay, so now, okay, result equals, and I was trying to mush these together, but no luck. Oops, where am I? No luck. So let me just try echo $I. So I didn't see anything come out. For I, well, let's see if I even get into this part. So echo, the number was greater than or equal to 2. Okay, so it was. So then in here, now looping. Okay, so we did go through the loop. Um, echo $I. So now looping 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's as we want. But, so we never got this. Numbers sub $I. Okay, so I think I'm close. Bash array check if value exists, something like that. Check if a bash array, no, that's not it. So I wanted to say numbers. Oh, you know what? That warning it kept giving me was very correct, actually. The arguments can never be equal. Okay, so use not equal to compare as string or expand explicitly. Okay. Okay, so now looping. Um, echo numbers sub $I. Use braces when expanding arrays. Okay, so there's nothing there. Now here, can we do this? Okay. So if, so I want to say equals or, and then say the same thing here. Numbers sub $I. Wait a minute. So here is prime, is what we want to say. Okay, so I saw is prime on 2, on 3, on 5. Oh, well, that looks correct. So let me get rid of some of those. All right, all right, all right. Let's get rid of some of these. Two, 3, 5, 7. Okay, so that seems better. Let's see what the test says. All right, so output differs. Let's see. So I've got, okay. All right, so I have an extra space in there. So I don't want this space. Let's say result equals, well, let's see here. Result equals empty, and then we don't want that, and then or, for comparison, use what? Bash comparison equals. Okay, so we want this. Missing space before this. Okay. You need spaces around the comparison operator. So now that says okay. So I don't know how long did that take? That felt like it took a lot longer than it actually did. But hey, you know what? I'm happy. I'm happy. And honestly, like what I'm happy about is I just feel like this is gonna like help me. Let me get rid of that extra comment. I feel like this is gonna help me to not be so, bad at everything next time I try anything. Okay, so let me cat that. Okay, so here's our results. So if it is less than 2, echo nothing. So else results. Yeah, I mean, it's a little goofy. The Zig one was pretty ugly too. But yeah, that's basically it. So let's submit, and then I am going to do the other one, which is Fortran. Fortran, that'll be exciting. Okay, so this one says passed. Let's mark as complete. Okay, let's close all these bash ones. Next up is going to be Fortran. I do still feel a little under the weather. I'm going to step outside for another 5 minutes to clear my head again. And we are going to jump into Fortran. Okay, Fortran, but I'll be right back. 5 minutes, 5 minutes. All right, so it just occurred to me when I went outside, it just occurred to me that I've been doing the sieve completely wrong. I had forgotten that I'm just supposed to jump from one to the other. I don't know how to do it in Bash, but let me just take a quick look. So here, this J in sequence, this should not be like that at all. It should just be J plus equals I every time. And then we don't even need to do this mod check. I'll leave it alone, but let's try and get it right when we do the Fortran one. Because that's actually a fairly dumb mistake. I'll try to do it right on the Fortran one. Okay, so I think CMake should be okay. Brew install. Yeah, sure, let's try it. Alright, so CMake is installed, cool. Yeah, don't need to reinstall. And we can copy this hello world. GCC specs, okay. So let's do this. Okay, we're gonna look at Fortran. Here we go, baby. Fortran, hello world. Let's take a look. So if I try running the test, what will it say? It will say no target specified and no make file found. Stop. Okay, okay. So let's see what it says in the help. Oh, this is kind of a lot. Oh my gosh. Okay, okay. So running the tests, sure, a CMake build recipe. Okay, so working through each exercise is a process of creating the initial build with CMake. All right, satisfy compile errors to make the test fail. Okay, yep. And so each exercise will bring a CMake lists text file. And so we should use the recipe to handle the build. Cool. Okay, so should we try, okay, so create your initial implementation files before running a CMake. Sure. I think it's fine. So then it said we're gonna run CMake -g -big G. Okay. It says no generator specified. So it looks like last time I had Unix make files. Is that suggested here as well? All right, let's try it. All right. So now let's go into our Fortran file, which is what? Hello world dot F90. Okay, nice. So if we run the test again, we say built target hello world. And so it doesn't, so there's no, So it's okay. So before it said, wait a minute, wait a minute. Is it running a test? Oh my gosh. All right, so let's look in the test file. So test one, say hi, assert equal, implicit none. Did it run the test? I'm not even sure. Running tests via make. Okay, let's break it again. Okay. Nope, it's not running the test. Let's see the help again. So when all build errors are fixed, run the tests, ctest-v. Let's see what happens. It says expected hello world, got hello world. Okay, okay, cool. Okay, so ctest-v. Oh no, it says failed. Oh, did I not oh, we have to run the make again, right? Except I was running exercism test. So what is the let's see the make again. So to make it, we are supposed to just run make, I think, right? So make, and then ctest. Oh, not that. Okay, so now it says passed. Okay, so let's submit. Oh, except, what does it say we're supposed to submit? Submitting. Just the F90 main file. Okay. All right, let's see how it goes. So we'll go exercism submit hello world dot F90. Okay, let's see what it says. So let's see, is 14 a prime number? Type the following command and press enter. Power config / energy. Let me see. Well, I don't have a power config. I don't know. Is 14 a prime number? Okay, let's see. So if we do our bash civ sh and put in 14, it says 13 is, what if we do 41? We skip 14. I don't know how it could be not a prime number. I don't know. All right, so anyway, let's see what we got in here. Oh, still processing? Okay. Arc is complete. Cool. Love it, love it. So now let's go to the civ. All right. Civ. Let's take a look. All right. Okay, so first of all, let's see. What am I going to do first of all? So first of all, I guess I'm going to just go ahead and put my most recent civ file into my F90 file for reference, because I'm kind of dumb. I could use the reference. Okay, so now I'm going to go in here. This one. Okay, so I put that in there. All right, so now Fortran comment. Michigan Technological University. Okay, so we can use a comment liberally. Okay, cool. Okay, so we just put a bang in front of whatever we want to be a comment. Okay, let's see if I remember this thing that I supposedly learned. So we go to V block, we highlight what we want, we press I, and then press the letter that we want. Yay! Okay, cool. All right. Okay, so that's commented out. So function primes limit result array, cool. Integer intent in limit, okay. Integer allocatable array, all right, sure, I guess, I don't know. Replace this line with your implementation. All right, I guess so, I guess so. Okay, so first step, if the limit is less than 2, if limit less than 2. Okay, so now let's look at Fortran. I don't know any Fortran syntax, I don't think. Fortran if statement. Let's take a look. Michigan Tech. All right, so we're going to say if. Do you think it has to be like in shouty case like this? I'd rather not. I think it's probably okay if we do lowercase. Okay, so we'll do that. Then we'll say then. Okay, so then what about Fortran function return? Oracle? I don't know. I think we just go return. That's probably fine. Do we need a semicolon? It looks like probably yes. Maybe? I'm not sure. This is Fortran, right? Okay. And this is Fortran? Fortran 77? Wait a minute. Oh, no, no, no. The C version had a semicolon, I think. Okay, so no semicolon. Yay. Okay, so then we'll say end if. Oh, let's not make it. So end. Okay. I love that. That looks nice. All right, so then the next step, we're going to have result and numbers, I guess. Okay. So the result should be an array, and the numbers are going to be an array. So Fortran array what? Array definition, maybe? Declaration, maybe? Fortran lang, okay. So let's see what we've got here. Array slicing. So we did array1 equals all of this. Cool. Implied do loop constructor. That looks nice. That looks really nice. Okay, so in that case, I am going to say... Let's see. Array1, I equals 1 through 10. Wow, and set all element... Man, I like these. These look really nice. These look really, really nice. Okay, cool. So, man, yes, I love it. Okay. So, Do we need a dynamic array? Yes, the result should be a dynamic array, probably, right? And it does say that this result getting returned is an allocatable, so that's a dynamic array, right? And it's just called array. Okay, cool. So can I say, wait. Okay, so I'm gonna say that we have an index, so idx equals 0. That's where we'll start. Okay, cool. Let me put a comment here. Actually here. So the index into the dynamic result. Okay, just remind myself. And then I'm going to say numbers equals, and it's going to be pretty much like this. I equals 1 through 10. I equals, in this case, 2 through limit, I believe. Okay, cool. All right, so now for the for loop. Have we looked at that yet? Let's take a look. Fortran for loop. Yes. Oh, do loop. Has only one loop, the do loop. Okay, cool. Sounds like a winner to me, baby. All right, so do 10, I equals 1, n. Wait, what does this mean? Do loop is used for simple counting. All right, the do loop corresponds to a for loop. Okay, love it. So they put do, then they put a number. Oh, that's a statement label? Oh, really? Okay, fair enough. Okay, so this one skipped the label, right? Yeah, let's skip the label. So we'll say do oh man, I love it. I love it. I love it. So we're gonna say do I equals, and then here we went 2 through limit, right? So sure, 2 through limit. Okay. And then we'll end do here. Okay. So now we need to say, let's see, if numbers sub I, no. So if numbers sub I minus 2 is not equal 0, right? Oh, that bang is not it. Okay, what's the not equal operator? Fortran not equal operator. Operators, tutorials point, okay. Relational, okay, so we'll do a slash, love it. Not equal 0. Then, okay, so here we'll end if, and if. All right, so then here we are going to say array sub index plus plus equals I, okay? Sure. Let's see, was there something else? Oh, is plus plus in here? No, I don't think it is. So let's just not do that. Okay, so we'll say sub index equals I, index equals +1. Okay, sure. Then we need to go do another do. Okay, but here we don't want to count through everything. We want to count properly this time and actually skip ahead. If you type yes in console and press enter. Oh, how come it's like this? Oh, all right, all right. I didn't know it was like this anyway. Yes to everything. Okay, love it. Anyway, all right, so what were we trying to do here? So now we want to go do, but for this do, we don't want to... Yeah, we want to skip. Okay, yeah, this should be perfect. So here, we are going to do... We're going to say I equals... Or no, excuse me, j equals this time. We'll start with I. No, we start with I plus I. We start with I plus I. We go as high as limit, and we jump ahead by I. Right? Okay. So end do here. All right, so then the last thing we have to do is just say numbers sub j equals 0. And then at the end we don't have to do anything. I think that means we're done. Okay, so now let's try make. Okay. And then let's try make like this. All right. Here we go. So, ooh, that's kind of a lot. Make. Okay. Alternate return statement at 1 is only allowed within a subroutine. Okay. So let's not do that. Instead, we basically want to say greater than or equal to, and then just end the if down here. Okay. Make. So, oh, parentheses. Left out the parentheses. Make. If number, okay, co-array designator at 1, but numbers is not a co-array. I might come back to that one. Let's see, which of these do I know how to fix right away? Symbol I at 1 has no implicit type. Oh, shoot. Symbol J at I has no implicit type. Okay, so I think these might have led me wrong a little bit, maybe. Maybe? Because we said do I equals 1 through 10, which sounds great, but I don't think it quite worked the way I might have hoped. So we said do j equals I plus I, limit I. Symbol j has no implicit type. Messed up, messed up. I think this might have led me slightly astray. (2020 through 2022) Fortran community. Interesting. So let's see. So if we look at a different version, it had to have a wait, shoot. I equals 10. So here they put integer. So I think that's what we need. If it has no implicit type, then we need to just list a type someplace. So this one has no type, so I just want to say integer j. And this one similarly, integer idx. And then there were some other ones. Let's see if that fixes any of them. Okay, so we said integer j, array, I messed it up. Unexpected data declaration statement at 1, tisk. Okay, so the data declaration, perhaps that has to go up here. Maybe? Is that it? Yeah, I think that's better. Okay. So any others? Expecting end do statement at 1. Okay, so I messed something up here. So do and do, cool. If and if, sure. Do and do makes sense. If and if. Okay, so how did I mess it up then? Do here and do. If here and if. So what is it? So it's on 16? No. And if. It's on 25. On 25 I have end if and it says expecting end do. Okay, let's look again. Yeah, I'm right here. So I have end if, because I have this if here, but it was expecting end do. I definitely a skill issue here because I don't know why it would say that. Okay, so I have if, then, end if. Oh, wait a minute. I wasn't sure it should be like that. Nope, that's no good. That doesn't help. Okay, let's go back to the way it was. Okay, so let's look at this one. Co-array designator at 1, all right? But numbers is not a co-array. Okay, so I don't know what that is. Fortran co-array designator. Maybe something? Co-array. No. This one? Okay. Introduced co-arrays. Okay. Co-array designator. I don't quite know what I did. Okay, so numbers here. And then it says something about a co-array designator. Is it because the I minus 2 is here? Integer idxi. So I'm going to say idxi equals I minus 2. And then here, idxi. Nope, it does still say co-array. Let's see, array section designator is required besides the co-array. Oh, shoot. Symbol numbers at 1 has no implicit type. Okay, I can fix that one. So numbers should be array. So like that. Should it be allocatable though? I'm not sure. Let's see. Array numbers cannot have a deferred shape. So I think we want to say allocatable. Is that better? Yes, that is better. All right. Okay. Array section designator is required besides the co-array designator. Okay, let's see this one. Not a co-array. Okay, sure. I do not think I have the hang of passing arrays. Okay, so you misunderstand Fortran syntax? Yes, that's my problem. That's my problem for sure. So we want to use parentheses instead of square brackets. Okay, let's try that. That sounds like a good start. So we want to use parentheses. So here, I think the square brackets were okay. But here, this one should be round brackets or whatever. Okay. So was there another spot? This one. Okay. I can get rid of this comment now. Okay, okay. Oh, it built it. Interesting. So I guess this means I can run the test. All right, so, oh, seg fault. Yay! Hooray! Awesome. Invalid memory reference? Okay. I'm not surprised, but I don't know where it is. Fun. Okay, so arrays are not the same size. Expected something, but got something. So one test failed. Wait a minute. Okay, hold on. So we got invalid memory reference. So wait, so did it actually, wait, shoot, I do not know. So no primes under 2. Arrays are not the same size. Okay, so let's just try the no primes under 2 first of all. So if limit greater than or equal to 2, then this. All right. So, but what about like else? So what if it is like less than 2? What do we do then? So here we do something with this array index, but like, man, I'm not sure. Okay, so let me look again at the else if. Okay. So we just want to say else somewhere. Let's say else right here. Else array equals that. Make. Empty array constructor is not allowed. Fortran empty array constructor is not allowed. So it says we can have a zero-sized array. We just have to say what? Um, okay, so what if I try it using similar to the way numbers was, but here instead I say I equals 0, 0. What does that do? Okay, so it built it. Is the C-test any different? Um, let's see. Civ. Okay, so no primes under 2. Expected this, but got 0. Oh, shoot. Okay, so I did put a 0 in there in this case. So let's not do that. There is another way for a zero-sized array constructor. Is it this? I equals 1 to 0? Oh gosh, really? That seems crazy. Oh, okay, interesting. I think that's actually a little better. So now for our C test, find first prime. Okay, so I didn't manage to do that. Segmentation fault. Okay, so I know this. It's because I didn't allocate the array yet. So it's going to be similar to what I did, I guess, in Zig, right? So we want to say, so we want to sort of instantiate the array first, but then we want to, when we return, we want to do a slice of it, I think. So before we do the index, we'll say array equals, and so like with the Zig one, I'm going to say we want it to be 1,000 to start. Array size, max size 1,000 to start with. Okay, so then I think that should get rid of the seg fault, maybe. But then here we want to say array equals, and then we want to take a slice out of it. Let's see, Fortran array section. So here, yeah, we want to take a slice out of it, which is going to be 0 through IDX. Okay, let's see what it says. Make. It built. Okay. All right, so it says, did we still get seg fault? No, this is different. Okay, so this might be better. So test 1, find first prime. Oh, okay, interesting. So expected 2, but got 0. Okay, so that's not cool. Expected 2, but got 0. Okay. So when we put, let's see. So array equals, so I guess that probably should start with 2. Okay, I'm going to make this 2, and I'm going to make this 1,002. All right, so it says, okay, so expected 2 got 0. All right. Array, we're going to say we have some array to start with, I guess. And then we're going to do I equals 2 through limit, okay. Okay. So here we are trying to assign into the index. Yeah, all right, that makes sense, I think. numbers sub j equals 0. I don't want to end up with any zeros in the array. So idx equals 0. Numbers 2 through limit. We're going to do I equals 2 through limit. If this is not equal to 0, then we put I into our array. We increment our array index. I'm not sure this part is going to be working correctly. So j equals I plus I. Go through the limit. Jump by I. This doesn't seem right. So here, I'll say idx j equals j minus 2. This seems crazy. These all start to seem crazy. It's skill issues all the way down. Okay, so it says this. Now, some of these warnings might be helpful. Let's take a quick look. So do loop will be executed 0 times. Okay, so that one is as wanted. Numbers offset may be used in uninitialized. Numbers declared here. So maybe used uninitialized. Numbers declared here. Okay, sure. So we're not going to use it uninitialized. Maybe we should declare it at some other time. I don't know. Okay, I don't think these warnings are necessarily going to help me, although it would be smart to resolve these warnings. Probably. Okay, so yeah, expected 2 got 0. Realloc invalid old size. I don't know about that. Okay, so Fortran print. So you just put print on something or other. Let's see what happens. Okay, so we know we're trying to put something in here. So let's totally print I, print idx, print array. Can we do that? Just for a start? No, we need to use a format string, I think. Or do we? Print with a format string. Yeah, probably. But what about when they just used a star? All right, let's try the star. So they put a star and then a comma? Okay, let's try it like that. Okay, so try make again. All right, try test again. All right, so I got a lot coming out. So, I mean, I guess that's good. Yeah, I don't want to print the whole array. It's too much. So let's do... Okay. So are these what came out? 303414. Yeah, that's kind of confusing. Let's actually use a format string. So for the format string, we want to do I, and then just put RWM width, repeat. So I have to put, oh gosh. All right. Um, so IDX, no. Yeah, let's just say I1, I, and then 5 maybe. Maybe. IDX, 1I5. Array at IDX, 1I5. So what is the, oh, missing leading left parenthesis in format string? Oh, darn. Okay, so it's not like that at all. Print star I is print star IDX is print star array at IDX is, yeah. Expected comma in I, oh, yep. That's at 29. Okay. So here's what we tried to do. So I is 3, IDX is 0, array IDX is 3. So we set the 3, so that's good because that's a prime. But if we're just trying to find the first prime, then we probably shouldn't go that high. Let's see, what time is it? So I is 4, index is 1. Uh-oh, we set the 4 here. No, we shouldn't be doing that at all. Shouldn't be doing that at all. So I think I've done this part wrong. In fact, I'm pretty sure I've probably done this part wrong. So print star j, print star j is Okay, so we went, J is 6. Okay, yeah, 6 and 9, those are what they should be. Yep, for sure. Um, so I think for 2, in the special case, in the special particular case of 2, that's not working. And we need to figure that out. So it should probably be limit plus 1, I think. Yeah, here as well. Plus 1. So limit plus 1, limit plus, yeah, let's try that. Okay. So here it says, oh, okay, hold on. So sig abort, okay. I think that did not solve anything. Realloc invalid old size. That's the real problem here, right? That's what's causing it, the abort. And where are we seeing such a thing taking place? Numbers here should be 0. I think that part is okay. Zero through IDX. Wait a minute. Okay, so result is a keyword, but let's just say res array. So let's say that this one will be res array. And then where else do we have array? This one will be res array. Yeah, I think that might be required. Something like that. Let's see. So it says okay. So it still says sig abort, so that's not good. It says double free or corruption out. Hey, you know what? I think I fixed something by doing that. Double free or corruption out. All right, not a big surprise. I'm gonna come back and I gotta take 5 minute break again. I'm such a mess all the time. All right, I'll be back in 5 minutes. Okay. Oh, it's been a long one. All right, but I'm getting close to the end, and I'm gonna finish for the morning when I get to the end of this one. All right, so anyway, double free or corruption? Hate it. Okay. All right, I'm just gonna have to look. Where do we think it's double free or corruption? Okay, so if limit is greater than or equal to 2, then we'll do all this, sure. Um, let's see, can I fix this uninitialized thing? I think it's okay. Um, okay. Double free or corruption? Okay, I'm not sure where I think I should expect that to be. Did I see this getting printed out? No? Okay, so I saw a 2 and a 3 come out. Then it was all double free or corruption. Okay, so the limit was 2. So we shouldn't have gone to 3, actually. So this +1 is a mistake. I thought that maybe it was wanted, but apparently not. Okay, so here, expected 2 but got 0. Hmm, I'm back and forth going crazy. Okay, so double free or corruption. At a different place this time, though. I don't know about that. Okay, expected 2 got 0. Can we do print res array here? The res array should have a ton in there. But let's just look once. Okay, so the res array prints out. Interesting. Is it kind of weird that that's the way it prints out? It looks like it's starting with 4 of all things. 4, 5, 7, 5, 6, 7. Okay, I've done something really wrong here where I tried to change this. Okay, so J. So can we print this? Three, 4, 5, 7, 5. Interesting. 3, 4, 5, 7, 5. So in this case, it printed out 0. Man, I don't think I'm very close to finishing this. I equals 2 through limit. Zero, 2. Yeah, why do I have a 0 there? So yeah, I shouldn't have been 0, I don't think. Composite number found. See, I don't think it's the right number. Okay, so composite number found. Yeah, 5 is not. This should have been 6, I believe. And this should have been 9. No, I don't know, actually. Yeah, they're just not right. And I'm getting tired already. I just don't have much endurance. Okay, so let's see. Print finding multiples of print I. Okay, so finding multiples of 3. So this should have been 6. This should have been 9. Okay, finding multiples of 3, 6, 9. Finding multiples of 4. We shouldn't do that either. We should have found multiples of 2 before we did anything else. Has this number been found to be composite? Numbers, IDX. I've made this really confusing in a way that is really unhelpful to me. Okay, so 0. Okay. Let me get rid of these prints. Okay, pattern not found print. Okay, so this is fine. Okay, so if this, sure, I guess, index equals 0, that part makes sense. 2, so numbers should be 2 through limit. I should also go 2 through limit, I guess. Index I should be I minus 2. I think that's... Fortran is 1 indexed. I knew that already. And I hadn't been thinking of it this whole time. That was one of the few things that I previously knew about Fortran, was that it was 1 indexed. And Fortran is 1 indexed. I am crazy right now. That is one of the only things I ever knew about Fortran. Okay. No, this should be 1. Oh my gosh. Okay. This should be subtracting 1. That is one of the only things I knew about Fortran. And I didn't think of it until this moment. That is crazy. Okay. Fortran is 1 indexed. Oh my goodness gracious. Okay, so what does it say now? Okay, so expected 2, but got 2, 3. So I went too high. So the limit was supposed to be 2, and I went up to 3 because... So this is inclusive, right? Man, this is crazy. Okay, so let me... Okay. It's 1 indexed. Oh my gosh. That was... Alright, I'm gonna say it one last time. Fortran is 1 indexed. That was one of the only things that I knew about it. And it completely slipped my mind until just now. Alright. Let's look at the tests. Okay, so... Did we actually do these? The tests were created, blah, blah, blah. Okay, so it says 100%, 0 tests failed out of 1. So we only did 1 test, right? Or did we? Call assert equal, no primes under 2. Let me just go in here and see. Oh my gosh. One, 2, 10, 13, 1,000. So it did do all the tests. That is so crazy. That is so crazy. That one thing, I wasn't even thinking in that direction. Okay, so I am going to finish up. Let me just get rid of that. Do I have anything else? Oh, man. Okay, so test one more time. It looks good. Let's submit. That was interesting. I must say, I think the Fortran syntax looks really nice. I had completely not remembered at all that it was one indexed. That is so crazy. Okay, so let me make sure. I don't usually look, so my iterations, I just want to make sure that it's in there. Yeah, this is what I just wrote. Okay, so I'm going to finish up for this morning. Oh my gosh. That was mental. Okay, so I'm going to come back this afternoon. I don't know what Loon is. It looks like something with a credit card. But we're going to do TypeScript. We're going to try Perl. This will be the first one in Perl. Well, this will be the first one in TypeScript as well, but I know TypeScript already. And awk. Interesting. Okay. So I'm going to come back this afternoon and try TypeScript, Perl, and